1.5 is going to cover some rules with exponents or expressions with exponents. The first thing that I want to clear up here is when you have a negative exponent, a lot of your MCA tests will require you to get rid of a negative exponent. So we have 4 to the negative second. Basically what we do here is you go ahead and write it over 1, make it a fraction. Whatever base number has a negative exponent, you would move it. So in this case we move it to the bottom, giving us 4 to the second on the bottom. When you move it, it gets rid of that negative exponent. So if it was on the bottom, you'd move it to the top, move it to the bottom. 4 to the second then giving you 1/16. So to simplify, 2 to the negative second, make it a fraction. 2 is our base number. Negative 2 is that negative exponent. We now have 1 over 2 to the second. 1 over 2 to the second would give us option C, 1/4. All we want to point out here is the 0 rule. Basically anything to the power of 0, x to the power of 0, 2 to the power of 0, 3.14 to the power of 0, anything to the power of 0 is going to give you 1. So the 0 rule, anything to the power of 0 is 1. In the product of power rule, the product of power rule basically tells you that if you have the same base, so you're looking for the same base number. In this case, if we look at this example here, 4 is the base number. When you have the same base, all you need to do is add the exponents. So 2 and 3, 2 plus 3 giving you 4 to the 5th. Basically, it's saying that you have 2 4s and 3 4s giving you that 4 to the 5th. So product of powers, same base, you're multiplying, and when you multiply, think about it, you look at it like this, it looks like an addition sign that happens there. So when you have the same base, you're going to go ahead and add those exponents. In this case, we would get 5 to the 10th. I have 6 5s and 4 5s. Next example, again, same base of 5. It is multiplying. You would add those exponents, 5, negative 7, giving you negative 2. Again, we don't like using negative exponents, so we'll make that a fraction. This has the negative exponent. We move it to the bottom. We have 1 over 5 to the second, which we don't see in our answer. So we're going to take it a little bit further, and we have 1 over 25, 5 to the second, giving you A. With the quotient of powers rule, very similar to product of powers, you still need to have that same base. So in this example, you have 4 and 4. When you have the same base, you're going to subtract the exponents. This division sign looks like a subtraction sign. So you're going to take 5 minus 2, giving you 4 to the 3rd. Basically what this is showing you is on the top, you have 4 to the 5th. So you have 5 4s divided by 4 to the 2nd, where you have 2 4s. You get rid of these 4s, leaving you with 4 to the 3rd power. So down there, next example, same base, 9, 9. When you have the same base, you would subtract exponents. So I'd have 6 minus negative 2. Minus minus is a plus, so you would have 9 to the 8th power. Our next example, 3 to the 8th divided by 3 to the 2nd. Again, same base of 3. You have 8 divided by, which looks like a minus, 2. You get 3 to the 6th power, D. Again, with product of powers, quotient of powers, the most important thing there is making sure that we have that same base number, and then we need to add or subtract those exponents. Last rule here would be power to power. When you have a power that is raised to a power, so we look at this example here, 5 to the 2nd raised to the 3rd. When you have an exponent raised to an exponent, you multiply your exponents. So 2 times 3, giving you 5 to the 6th. We have our base number 3. We have a power raised to a power. I'm going to multiply. And we have 3 to the 12th power. C, power to power. When a power is raised to a power, multiply. So if we look over on the next answer here, everything is raised to the 4th power. Okay, 15 really has an exponent of 1. 2 really has an exponent of 1. So I'm going to raise everything to the 4th power. Power to power, 1 times 4, I get 2 to the 4th. Power to power, I get 5 to the 12th, 3 times 4. Divided by power to power, 15, 1 times 4 is 4. Now you look here, look at your answers A through D there, nothing looks similar. So what you need to do is actually break this down a little bit further. So I'm going to go ahead and prime factorize this number here. 15. To get to 15, I have 3 times 5. 3 times 5 would give me 115. So if you think about it, 3, 5, 3, 5, 3, 5, there's 115, there's 2 15s, there's 3 15s, there's 4 15s. Okay? So essentially what I have is 4 3s and 4 5s to get me 4 15s. So I'm going to go ahead and rewrite that denominator as 3 to the 4th, 5 to the 4th. So 3 to the 4th, 5 to the 4th, we have this is gone, and that is also gone. We just rewrote that denominator. Now when I look at this problem, I can go ahead and do my quotient of powers rule. So I look for the same base. Well, here's a base of 5. Here's a base of 5. What's happening? Well, I am dividing. So I'm going to go ahead and move my 2 to the 4th out because there's no same base. I'm going to move my 3 to the 4th out. There's no same base. But I do have the same base here. When I have the same base there and I'm dividing, I am subtracting my exponents. So I would have 5, 12 minus 4, giving you 5 to the 8th power. Now you look over in your answers here, and you would find out that is option A. This will conclude rules with exponents.